Example number 2, we want to differentiate the function f of x equals secant x over 1 plus tangent x. So we see that we have a quotient here, so we will apply the quotient rule. So the derivative of the function f of x equal, the function g is 1 plus tangent x times the derivative of secant x minus the function f is secant x and times the derivative of a function g, so which is 1 plus tangent x, then divided by g squared, 1 plus tangent x squared. So we copy down the 1 plus tangent x again, and we just learned that secant x, the derivative of secant x is secant x times tangent x, and the derivative of tangent x is secant square x. So we will apply them for this step. So secant x, the derivative is secant x times tangent x, and minus secant x. The derivative of 1 is 0. The derivative of tangent x is secant square x over 1 plus tangent x squared. Now on the top, we will open the parentheses, so we will get secant x tangent x plus secant x times tangent square x. So we distribute, and then minus secant qx. So what do we see is that we can see that the secant x is the common factor. So we can factor out the secant x. So we will get the tangent x inside the parentheses, tangent square x inside the parentheses, and secant square x inside the parentheses. We recall from trigonometry identity is tangent square x plus 1 equals secant square x. That means if we do tangent square x minus secant square x, then we will get negative 1. So this right here means negative 1. Then the next step will be secant x times tangent x plus negative 1, which is minus 1, over 1 plus tangent x squared. So we finished finding the derivative of the function f of x. Now the second part of the problem says that for what values of x. So this statement means 5x. Does the graph of the f have a horizontal tangent? Horizontal tangent is a line horizontal. So horizontal line has slope equal to 0. But the definition of the derivative, the first derivative is the slope. So what we need to do is we set up the derivative equal to 0, then we find the value of x that makes this equal to 0. For the fraction to be 0, the top have to be 0 because the bottom square, so it's always positive already. And if you recall that the secant, the graph of the secant is something like this and then like that, right? So it's never 0. So in order for this statement to be 0, then the tangent x minus 1 have to be 0, because we know that the secant x is never be 0. It could be more than 1 or less than negative 1, but it's never 0. Then the tangent x equal to 1. And we recall that in trigonometry, we're going to wrap the unit circle. So right here, we have the point pi over 4. The angle pi over 4 give a square root of 2 over 2, square root of 2 over 2. So sine is square root of 2 over 2, cosine is square root of 2 over 2. And the tangent is sine of x divided by cosine of x. And only when we have the angle is pi over 4. And also we have another angle is right here, which is 5 pi over 4. This is also negative square root of 2 over 2, negative square root of 2 over 2. The tangent also give 1 also. So we have these 2 points, and because they're in the special position, one go to the other is pi length. And also from 5 pi over 4 go to pi is also pi length. So I'm going to choose the smaller one. So x equal pi over 4 and then plus n pi. It's a multiple of pi to go to the other one. Okay, so the answer is when x equal to pi over 4 plus n pi, for n is an integer. Integer mean plus minus 0, plus minus 1, plus minus 2, and so on. Then we will have the horizontal tangent for this problem.